Are we alone in a cosmos filled with countless stars and galaxies? Or have we finally solved the greatest mystery of the universe? It is both exciting and terrifying to consider the possibility of a new civilization. We begin a journey of revolutionary discovery today that has the potential to alter everything we know about universe-wide life. A wave of curiosity and excitement has been sparked by an unprecedented discovery made by the James Webb Space Telescope 7 trillion miles from Earth. What if we weren't the only ones? I think the Milky Way might be home to a civilization right now. Good gracious, unimaginable. Over the next 10 years, we will gain a lot of knowledge. The James Webb Space Telescope has made an unprecedented discovery. City lights in space, 7 trillion miles from Earth. The possibility of extraterrestrial life has been strongly sparked by this remarkable discovery. Unusual light emanating from the closest exoplanet to Earth was observed when the telescope was focused on Proxima Centauri b. On Proxima Centauri b, what could be causing these city lights? Could this indicate that life exists beyond our own planet? We should investigate how the James Webb Space Telescope identified these impossible-to-miss objects in space. The disclosure of city lights on Proxima Centauri b by the James Webb Space Telescope could be the primary strong proof of extraterrestrial civilizations. Scientists and the general public have been looking into life beyond our solar system for a long time. The reception of any evidence in support of this space fantasy has been enthusiastic. As of late, established researchers with stunned areas of strength for when of living things existing in space was seen by the James Webb Space Telescope. Strange city lights emanating from the exoplanet Proxima Centauri b were observed by the James Webb Space Telescope as it traveled through space and relayed crucial data to Earth. These city lights appear to illuminate a faraway city. As the name suggests, scientists have been taken aback by the possibility of an alien city in our star system. In the event that it ends up being valid, this implies there are shrewd living things putting together civilizations a long way from what people know in space, and we are just barely finding it. The discovery of an extraterrestrial city on Proxima Centauri b could alter our perspective on the cosmos and our place in it. NASA engineers wonder how long these cities' lights have been shining in space, waiting for humans to develop the technology necessary to detect them, as they observe them 7 trillion miles away from Earth. David Kipping, a space expert at Columbia College, portrayed Proxima Centauri b as a test. The heating patterns in the star system closest to us are distinct from those on other planets. Planets made of regular rocks take in sunlight and give off infrared radiation. Notwithstanding, Proxima Centauri b's infrared nature is very not quite the same as its host star, Proxima Centauri. The James Webb Space Telescope is able to make useful observations because of this. It has been demonstrated that the James Webb Space Telescope, JWST, is the best instrument for the job. It is able to quickly detect Proxima Centauri b's heat signature and infrared wavelengths, both of which will be crucial to figuring out more about its atmosphere. Could the advanced infrared capabilities of JWST shed additional light on the atmosphere and potential for life on Proxima Centauri b? Researchers intend to utilize the telescope to investigate the secrets encompassing the planet's environment and conditions. They want to test the exoplanet's habitability with the Webb telescope. On Proxima Centauri b, the James Webb Telescope has the infrared sensitivity necessary to observe nighttime activity by capturing the tiniest rays of light in the cosmos. Space telescopes typically face difficulties in capturing even the tiniest rays of light from space, but JWST has overcome these obstacles. It is the ideal instrument for determining whether or not the dark side of Proxima Centauri b has city lights. A telescope can pick up any artificial light in the universe as long as it has a frequency band 1,000 times narrower than starlight. The first concrete proof of extraterrestrial civilizations could come from JWST's ability to detect faint artificial light in space. How does Proxima Centauri b contrast with planet Earth? Surface interactions and stellar properties interact in a fascinating way in Proxima b. Numerous solar panels on the day side of the exoplanet harness the star's radiation energy. Light rays from the star are also reflected by the spectral edge. Similar to our day and night cycles on Earth, Proxima b experiences warm, solar-rich days as it completes its orbit around its host star, Proxima Centauri. It is known that the planet's composition influences fluctuations in temperature. On Proxima b, for instance, the day and night cycles would differ significantly and evenly if there were no atmosphere. The day side would be as hot as a black body, and the night side would be plunged into terrifyingly cold darkness without the atmosphere and ocean's moderating influence. Astronomers can gain a better understanding of the atmospheric composition of Proxima b by studying the magnitude of the temperature variation. Could Proxima Centauri b's unique temperature fluctuations and atmospheric composition be the key to understanding its habitability? JWST is able to effectively examine the planet's thermal emissions and provide pertinent information on its atmospheric properties thanks to its unrivaled infrared imaging capabilities. It is interesting to note that JWST's orbit around the Earth coincides with Proxima b's, making it possible to observe the spacecraft's entire day and night cycle for 11 Earth days. The next step will be to examine the chemistry of Proxima b's atmosphere to see if it could support life, because it does have an atmosphere. The presence of gases like methane, oxygen, and water vapor is a good sign that there is life on the planet. On the off chance that these components can be found, it implies the planet upholds livable circumstances. Scientists must meticulously capture and examine light rays passing through the planet's atmosphere for a successful conclusion. Even though JWST has excellent capabilities for describing planetary atmospheres, this is a very difficult task. The confirmation of Proxima Centauri b's habitability may begin with the discovery of key gases in its atmosphere. Additionally, JWST intends to investigate shifts in the concentrations of methane, carbon dioxide, and water vapor. Nonetheless, with regards to deciding how much bound oxygen, a vital sign of life, JWST is restricted. Nevertheless, telescopes have good reasons to look for other planet features like ozone, which gives the atmosphere its precise energy levels. It's important to remember that the James Webb Space Telescope isn't all-powerful and can only look at some of the planets closest to Earth that are habitable. Astronomers are turning to ground-based observatories like the Extremely Large Telescope, ELT, affectionately known as the YELT, for more in-depth studies of the atmosphere. The ELT, which is scheduled to begin operation in 2028, is carefully positioned to investigate the atmospheric structures of exoplanets further. When the ELT goes live in 2028, what secrets will it reveal? Could it find evidence of life on exoplanets far away?